Hello friends. So in today's question, two blocks are kept on an incline in contact with each other. The masses of the block are m1 and m2 and the coefficient of friction are mu1 and mu2 respectively between the blocks and the inclined plane. The angle of inclination is alpha. Show that the force of interaction between the blocks is given by mu1 minus mu2 m1 m2 g cos of alpha m1 plus m2, and the minimum value of alpha at which the blocks just start sliding is given as alpha tangent inverse mu m1 plus mu2 m2 and m1 plus m2 divided by rather, not and. So first of all, let us draw the figure. So this is inclined plane having angle of inclination as alpha, and we have two blocks m1, and let us draw a little bigger one. This is m1 and this is m2, and the various forces which will be acting m1 g, and there is similarly m2 g. So we can divide m1 g into 2, so this will be alpha, so we get this as m1 g cos of alpha, and this will be m1 g sin of alpha, and let us suppose there is a normal n1, and similarly we are going to have this is our alpha, so this will be m2 g cos of alpha, and this we can say m2 g sin of alpha, and we have a normal, let us suppose that is n2, and if they are moving both in the downward direction, so there will be friction for m2 will be our fr2, and for m1 it will be our fr1, and there will be a contact force, let us call that as n. This is the contact force n which is acting in between the blocks. So let us first of all write for block m1. So you can see for block m1 we have n plus, we have downward direction as m1 g sin of alpha, so we have m1 g sin of alpha, and the friction is given as fr1, so this will be fr1, okay, and acceleration, okay, yeah, and acceleration is given as a, so we have m1 a. So let us call this as equation number 1, and similarly we can write for block m2 we have m2g sin of alpha, and this will be minus of n and minus fr2, this will be m2 a, and let us call this equation number 2. So in the first case we are going to find out the force of interaction between the blocks. It means we are basically interested in finding out what will be our n. Okay. So what we do, we multiply equation by m2, 1 by m2, and equation 2 by m1 and add them. So we can say equation 1 is multiplied by m2 and equation 2 is multiplied by m1 and adding them. We can write it from here. We get m2n plus m1 m2g sine of alpha minus m2 fr1 is equal to m1 m2a. And the second equation, we get this as not adding, we have to subtract them, that's why it's okay. So now we multiply this with m1 m2 g sine of alpha minus we have m1 n and minus m1 fr1 is equal to m1 m2a, and we are going to subtract them. That was a mistake on my part. So we say minus, plus, plus and minus. So this cancels out and this also cancels out. Okay. So we are left with, taking n as common, we have m1 plus m2, and from here we get plus fr2. So this will be equal to m1 fr2 minus m2 fr1 is equal to 0. Now it is only simple. Moving from left to right, you can say n is equal to, here this is m2 fr1 minus m1 fr2 divided by m1 plus m2. So this is our normal n, and we can find out our fr1 as well as fr2. You can say for block m1 we have fr1 which will be equal to mu1 into n1, and we can write fr1 is equal to mu1, n1 is equal to our the vertical component of cos theta component rather. So we get this m1g cos of theta, and for block m2 we have fr2, this will be mu2 into n2. From here we can say fr2 is equal to mu2 m2g cos of theta. Now substituting these values, we get n is equal to, the equation was fr1 m2 minus fr2 m1 divided by m1 plus m2. So if substitute in this equation, we can say our normal is equal to fr1 is our mu1 m1, and we can take g cos theta as common. So we get this as mu1 minus mu2, and this will be m1 m2 g cos of theta divided by m1 plus m2. So this is our first part. Okay, we found out what is our contact force. In the second part, we are supposed to find out what will be the minimum value of alpha at which it starts sliding. Okay, rather not find out but prove. This is hence proved, first part. For the second part, the minimum value of this acceleration. Okay, so we already know that our for sliding, okay, as both of the blocks will be sliding now, we can say that for sliding the FR1 will be equal to maximum value of FR1, and which is equal to mu1 m1 g cos of alpha. Sorry, here it's alpha, not theta, my mistake. And FR2 is equal to FR2 max, which is equal to mu2 m2 g cos of alpha. Okay. And for this condition, okay, we can say the algebraic sum is equal to 0 along the inclined plane. Along the inclined plane. Okay, that's for sliding. Algebraic sum is equal to 0. So we can write this as m1g sine of alpha plus m2g sine of alpha minus fr1 minus fr2 is equal to 0. We can take m1g sine alpha plus m2g sine alpha is equal to fr1 plus fr2. Taking g sine alpha common, get g sine alpha m1 plus m2 is equal to fr1 is mu1 m1 plus mu2 m2, and g cos alpha is a common part. G and g cancels out, so we can say this will be coming as tangent of alpha is equal to mu1 m1 plus mu2 m2 divided by m1 plus m2. From here you can say that agar alpha is equal to tangent inverse of mu1 m1 plus mu2 m2 divided by m1 plus m2. So this proves the second part. Hence proved. This completes the question. Thank you.